thesis focused on my thesis focused on nutrient concentrations found in stormwater effluent, specifically flowing into Long Lake, a freshwater lake located in Lacey, Washington, where that stat is. Long Lake is a haven for residents. Oh my goodness. Here, hold on a second. We're gonna start this over. Just close your eyes while I back up all the pictures. Something had to happen. Okay, there it is. Okay. So Long Lake is a haven for residents and recreators and a critical asset to the larger Lacey community as it serves to recharge groundwater and local drinking water aquifers. However, the lake has been inundated by cyanobacterial caused algal blooms due to the lake's poor water quality as a result of urban development and the abundance of nutrients. While not always toxic, they are noxious to sight and smell. So, and to underline this, the algal bloom that occurred last summer in 2020 lasted for a long time, all the way up to February of 2021 while we were doing our sampling. So the thick mats of biomass that these blooms produce and they form at the surface actually block sunlight and deplete oxygen to the aquatic life below the surface, which disrupts the balance of the lake's own aquatic community. The oxygen can become so depleted that the lake will experience fish kills, which in of itself occur, but it can occur more frequently and more often due to these blooms. So even though the blooms are not always toxic, it still takes a screening test to determine whether the lake is safe or not from cyanotoxins. 6 of the past 10 years have tested positive for microcystin, a hepatotoxin, which impairs liver function, and 1 year for anatoxin alpha, a neurotoxin, which impairs brain function. So I got too many screens over here. Okay. Now, even when the lake does not measure above recreational guidelines for cyanotoxins, a small amount may still be present. And frequent exposure is associated with chronic illness, including liver cancer, digestive and skin diseases, neurological impairment, and even death. And children are more likely to be affected due to their size. So here is a conceptual diagram of nutrient cycling in aquatic environments. And it's due to the environmental and human health risks associated with cyanobacterial harmful algal blooms that it's imperative that nutrient reductions be taken both internally and externally. So nitrogen and phosphorus are the nutrients of highest concern, as their abundance allows cyanobacterial blooms to flourish. This is especially important considering that the cyanobacteria microcystis, which releases the cyanotoxin microcystin, is the leading cause of lake closures at Long Lake. And unlike cyanobacteria that can fix nitrogen, which is a process by which nitrogen is taken from the atmosphere, microcystis requires nitrogen to be readily available. It is when nitrogen and phosphorus are abundant that microcystis can dominate, including over less toxic cyanobacteria species. So Long Lake is like most freshwater lakes, is a phosphorus limited system. This is due to the limited natural abundance of phosphorus. However, when phosphorus is readily available, especially as it is in the form of soluble reactive phosphorus, SRP, there's no limiting factor for cyanobacterial growth, and excessive phosphorus effectively destabilizes the lake's natural balance. So I have a couple areas circled on this diagram, which the Long Lake Management District has been and continues to focus their water quality management efforts, including residential sources, of which stormwater belongs. I have the internal cycling of Long Lake, which is a eutrophic lake, which means it's highly productive, and thus the aquatic organisms both recycle phosphorus and through decomposition continue that cycle within the lake. And then groundwater is a huge input of water into Long Lake, about 75% of which nutrients are transported, and then wastewater through leaking septic tanks. So And for the purposes of the study, that's why we focused our sample analysis to be on total nitrogen, total phosphorus, and soluble reactive phosphorus, SRP. And SRP is a form of phosphorus, but is the most bioavailable form for aquatic plants, algae, and cyanobacteria. So this takes me to the water quality management that Long Lake performs. They're actively engaged in invasive plant management, internal phosphorus loading. This picture is actually from their recent aluminum sulfate treatment, which sequesters phosphorus in the water column and takes it down into the sediment to be stored for a number of years. And they're now turning their attention towards stormwater, to which this study belongs. So this is an initial study. As you may know, stormwater is the primary source of water pollution in the United States. We were looking, Long Lake is a heavily urbanized residential area, so it has a high area of impervious surfaces, which transport accumulated nutrients, petroleum, rock salt, trash, heavy metals, as it does in most parts of the United States. And like I was saying, the study is an investigative survey. It's ongoing, and we identified our samples took place in 2 stormwater outfalls, one in the North Basin here at Casino Outfall, and one in the South Basin here at Lorna Outfall. And then we had a number of other sampling sites. And so we took these samples over the wet season from November of 2020 to March of 2021. And we collected 34 grab samples, which occurred during 3 storm events and on 2 baseline sampling occasions, which were to measure the day-to-day Long Lake nutrient quality. And additionally, I took some dissolved oxygen, pH, conductivity, and temperature measurements on 3 of those 5 occasions. So what did we find? We did find that nutrient concentrations from storm drain runoff was noticeably higher than the lake sites during storm events, especially from Casino drain, which appeared to be which was the greatest contributor of nutrients. And most of the sites, it was the earlier storms, November 3rd and December 16th, that had the highest concentrations of nutrients. And SRP concentrations were higher than baseline during those storm events and from the stormwater outfalls. So I'm going to draw your attention to some graphs. This is total nitrogen. These are all of the sample site. These are all of the sampling occasions and all of the sampling sites. The x-axis has the location, and they're roughly North Basin, South Basin, and in proximity to each other. So we have Casino drain, and then a Casino lake, which is 3 to 5 meters away from the outfall. The blue circle and square are the storm events, and then the red squares are the baseline events. The mean concentration is the black dashed line, and the red dotted line are the nutrient thresholds, either determined through state nutrient criteria or extrapolated from total maximum daily load reporting from this ecoregion. So total nitrogen has a bit more variability, but if we look at total phosphorus, we can see that the November 3rd storm was a huge contributor. And this is the highest sample reading that we received, 0.4 milligrams per liter of total phosphorus from the Casino drain. The storm events were the highest contributors of nutrients. And then SRP, this more bioavailable form of phosphorus, there's less variability amidst the sites, but it's specifically from the drains, the Casino drain and Lorna outfall. You can see the highest concentrations of SRP, which is indicative of the importance of storm events. Maybe I should just keep that up. Storm events and the transport through these outfalls. Now, one of the more significant findings that I had from the study was of the stratification of the lake. I took readings from January to March, and the lake was stratified, meaning that it was separated into layers for the entirety of that time, which is uncommon, which was not predicted by past reporting. And unfortunately, what this means is that because of the layers, dissolved oxygen concentrations, the layers are separated, so dissolved oxygen concentrations are used more quickly for longer durations of time due to the warming temperatures of the lake earlier. And conductivity, what was interesting to me was that the South Basin was always had higher readings than the North Basin. So I was curious to know if groundwater inputs were contributing to that. Was there higher residential effect in the South Basin? You know, more questions for the Lake Management District to discuss and to plan with their water quality program. So in conclusion, earlier seasonal storm events transported higher nutrient concentrations. Both storm drains discharged higher concentrations relative to the lake sites, especially at the Casino Drain. And the lake was stratified through the winter. And low dissolved oxygen means near 0 milligrams per liter of oxygen near the lake's floor at the bottom of the lake, which is especially important with phosphorus leak occurring in anoxic conditions. So this could nullify some of these alum treatments that the LMD is performing if what they're trying to do is, sequester it for as long as possible, but dissolved oxygen plays a role. So I made some recommendations to the LMD that year-round study of the lake's dissolved oxygen and temperature be recorded. Further analysis of nitrates and nitrites be taken, which is this more bioavailable form of nitrogen. And it was really interesting to me reading through the literature of the importance of basically the food chain effect in controlling lake productivity. And so it would be interesting to know which trophic levels, which species might be missing, and does that have any effect on controlling cyanobacteria, and are these fish kills of more importance? And then, as always, the importance of planting shoreline buffers and the ability for natural barriers to mitigate more bioavailable forms of nitrogen and phosphorus from entering the lake system. So that's it. I also just want to extend my gratitude over and over and over again to all of you. Thank you so much for being here. Special thanks to Paula Cracknell, the aquatic resource specialist who roped me into this study. I'm so grateful to Dr. Erin Martin for all of your time and input, and to my peers. Thank you, Danielle and Alexis, for all of your reviews. I'm just so excited to share this with you. So thank you again. I couldn't have done it without you.